All right. Good morning. Happy Tuesday already. Can't believe it's March. I guess we go, usually it's like by the time March is over, the term is over. We go until further into April term, but yeah, it just feels running out of time. Anyways, no, we're ticking along just like we should be, so we're good. Okay, so let's do a little bit of review. You've got an assignment due on Thursday. Assignment 5 is due on Thursday. Depending on how far we get today, I might bump it, but just as of right now, it's still due on Thursday at midnight. So assignment 5. Due on Thursday at midnight. So just make sure you have that under control. I knew there was something I was supposed to do. Just think it's the little things that kind of slip cracks or through the cracks. So I was going to go through and see which sections it covers. So I'll check that out after class and update it. But okay. So just as a little bit of review, right? We started talking about simple interest. So the idea being you, and it can go either way, right? You either go to the bank with some amount of money, you deposit it, and then you take it out after some of the time, and you get your amount of money and a little bit more, which is the interest, right? So your amount plus interest. Or you borrow money, so you borrow some amount of money, and then you have to pay it back, the amount you borrowed plus interest, right? Notice that these are that's the same situation, right? It just depends on which side you're on, right? So for review, we talked about I equal PRT, right? Where I is the amount of interest, right? So it's a dollar amount, okay, that you've made in some time t, right? Where P is the principal investment or loan. So it's the initial amount that you either deposit or borrow. It actually doesn't matter, right? There's going to be a borrower and a lender, right? So borrower doesn't sound like the right word, does it? Anyways, if we're borrowing from the bank is the lender and we are the borrower. I don't know, it doesn't matter. You'll know more about that than me. So R, being in business, I mean, lowercase r is the interest rate as a decimal, right? So this is the annual interest rate as a decimal, right? So if I tell you the interest rate, the annual interest rate is 5%, you would have to use 0.5, right? So we talk about interest rates in percentages, but then when we calculate, we use decimals, right? So here I'll just clarify, 5% use 0.05 in your calculations. And it has to be annual. Oops. It has to be the annual interest rate, right? Some of those problems that we saw used 1% per month, right? You'd have to say, okay, well, that's the same as 12% per year, right? So that's going to be important as well, that it's annual. Because it has to match the time. T is also in years. T is the amount of time in years, right? We'll end up with a decimal, and that's totally fine. Just try to keep all your decimal places unless it says otherwise. And so we did calculations where we solve for the amount of interest, how much did we deposit to make this happen, or how much did we borrow to make this happen? And then we solve for the interest rate. I'm pretty sure we solve for it as well. So we solve for each of these, and they'll come back up, but let's just kind of leave those for now, right? Where I want to pick up from last day is I want to talk about, okay, we talked about finding days between dates, right? So in order to find the time, if we have specific days, then of course we want to be as precise as we can. So what we'll do is we'll find the number of days between dates. So we also introduced how to find days between dates, the days between dates on our calculator. Okay. So on your calculator, right, you're gonna go, it's in one of the second menus. Let me go to our calculator here. Oh, looks like I haven't been here since we were here. It's okay. Above the number 1 button, there's the date function, right? So you're gonna go second date, and then just to refresh your memory from last day, right? We can scroll down between date 1, date 2, and the days between dates. And then I don't know what ACT is, but you can just ignore that. All right, so for us, we have three things of interest. Okay. So in the second date, okay, we have a menu with three inputs. We find a menu with 3 inputs. Okay. Date 1, which is the start date. Date 2, which is of course the end date. And if you scroll down again, DBD, right? And you can, is days between the start and the end date. Days between start and end dates. Sorry, it was really lagging in my class just earlier, so, and it seems to be lagging still. But then, of course, when Zoom asked me, hey, how's the quality of this meeting? I just default to great. I was kicking myself. It wasn't great. It wasn't great. It was lagging. So after this class, I'm going to tell it what's what, because it seems to be lagging still. So we can scroll between these, oops. Using the up and the down arrows. I don't think they're in that order, but I don't, that's okay. You get the idea. So using those arrows. And to change the start and the end date, what we said was, okay, we need to enter our date in a specific format so that it can read it. And so it's kind of weird. It's going to be month, dot, so use the period, day, day, year, year, and then you have to hit enter so that it'll actually store it. Okay. So here, to change the start / end dates, you need to enter the date using the format month, month, dot, day, day, year, year, and then hit enter. That's going to be really important because otherwise it won't save it, right? And so, and you'll know it saved it if it adjusts the how it looks on your screen. Okay. So let's see here. If we have 2 out of these 3, and it doesn't matter which 2 of these 3 inputs we have, we can always compute the third one, right? If we have 2, we can find the third. Okay. So given 2 of date 1, date 2, or the days between dates, right? Sometimes, you make a deposit on September 30th, and then 45 days later, well, what date is that, right? Then you can find, because you have date 1 and you have the between dates, so you can compute the third. So given 2 of these 2, or these 3, we can find the third. Okay. And what I want you to get in the habit of doing is, and we can show the one that's computed using a little star beside it in your work. Okay, so we can find the third and indicate that it was computed using a star in your work. So the reason that this is going to be important that you get in the habit of telling me which one you're computing is because later on we're going to have big problems that we're solving, but we're not actually going to do a ton of math. We're just going to let the calculator do all the work. And so then you need to, it's the equivalent of showing your work, right? Telling me that, oh, and then I let the calculator actually just do it, right? And that's fine, but you need to be able to show that somehow. So we're going to use the little star. Okay. So if we go back to didn't quite finish the example that we started. So let's go back there. Right, and so example 139, okay. We said, okay, so calculate the amount of interest. The amount of interest is going to be I, right? Put on a loan of, so the principal amount that I borrowed was $3,800, which was advanced on June 17th, 2005, and repaid October 1st, 2005. I do not want approximations. I want to know the exact number of days between these 2 dates. Okay, because I mean, we're talking money here, so it's going to be important that we do it properly, right? So, so what I want you to do is, I typically just write down, okay, first thing I need to do is find the days between dates because I need to find the amount of time. I'm going to copy this in. Just make a note that this is just all from last day. So from last day, we have all rats. I'm going to paste the image. We have all this. Okay. So let's just go through And we'll do another example after this. So for now, right, let's just refresh our memories. I converted the dates into that format that I need to enter into the calculator, right? Any work that you do to put stuff into the calculator, you should show me. You don't need to show this. This was just for me to see, okay, what were the dates? This is what I want to see, right? What you entered into your calculator. Because it gets a little bit weird when we're using our calculator for a lot of stuff, then the work that I need to see becomes what you put into your calculator. Okay. So let's just kind of go through the motions here, and let's enter 06 dot, now this period is really important, 06.1705, and then as our date 1. So let's just go through the motions here. Oh. All right. So I'm in the date menu. I'll go there again here. Whoops, clear. Second, date. Okay. This is the date that I'm interested in, but let's pretend it is. Notice that it has to show up in that format, otherwise it's not stored. So if I go 06.1705, I have to hit enter, right, before it'll store it. So that there's no equal sign after date 1. It's not until I hit enter that it'll actually store it. Okay? So it's going to be really important that you hit enter. Otherwise, it's not going to work. Then I scroll down to date 2, which I already know I entered correctly. So let's scroll down to the days between dates. And do you remember how we computed this thing? We said, I'm going to hit the compute, the CPT button up in the top left-hand corner is compute, and then it'll be 106, but we already found that. So, and like I said, we'll do another example. So, and it'll come up throughout the term. So that's why I'm not reading this one. I guess I sort of am. Okay. So now I have days between dates, okay, is 106. And remember, I just use a little star here by the between dates to indicate, hey, this is the one that I had to find. Okay, they use my calculator. So now we can say that time. So now we can say that T in years, right, is 106. Oops, 106 divided by 365. One thing that I will make note of here is that for this course, we assume all years had 365 days. I know that's, not the case, but that is an assumption that we are making. In this course, we will assume all years have 365 days. Okay. So just put that in your memory, right? We assume that there are 365 days in a year. Okay. So because you need to have time in the amount of years, right? 106 over 365 would be the number of years, right? Some fraction. Okay. So finding time was not the question here. It was just something that we had to do in order to answer the question. So if we go back, we want to find the amount of interest, which is I. Now, because I have P, I have R, and now I have T, this is going to be quite easy to find, right? So I'm just going to use that I equals PRT formula. So I equals PRT, which is going to be, P was 3,800, right? And then We already decided that R was 0.1075, so I'm just going to plug that in. Times 0.1075 times T, which is 106 over 365. I'm going to use exact values as much as I can, right? Especially as I'm just multiplying and dividing, I can do that in any order. So then from my calculator, the amount of interest is, I'm just going to calculate this out. So here we go. Okay. And you can do it in one go or just kind of break it up. It doesn't matter. Should be clear. Okay. So 3,800 times 0.1075. Multiplying and dividing, it doesn't matter the order as long as that's all I'm doing. So then times 106 divided by 365. 118.63287767. This is a dollar amount, right? The amount of interest. And so it's 118.63 cents, right? 0.6328. I wish I could copy that, but I don't think I can. Actually, I'm pretty sure I can't. 118.6328. No, it just kind of kept going. I'll see if I can get back. 6328767. Okay. Sorry. How about that? So then I, as a dollar amount, is 118.63 pennies. Okay. Let's do another example here. So that's kind of the end of stuff from last day. We didn't finish that problem last day, so here we go. Or there we are. But let's do another one where we use the days between dates function. Okay, so just as a heads up for later today, or I don't know when, I did add another example to this handout, and I updated the handout on Moodle. So, and that was this morning. So just if you have it from last day, you might want to update that. But I just added this last example. So, yeah.
Can you just show me the calculation for how you calculated the number of days?
Yeah, we're gonna do another example.
Okay, sure.
Yeah. Okay, so this is the one that we just did. Okay, 139. So let's grab example 140, and we'll use that as another example. Copy. It's so laggy, it's so annoying. Okay. On June 26th, okay, and it doesn't give us the year. So just as a note, if it doesn't give you the year, you're allowed to pick any year. And then, but just assume that unless it says, and then the following of September 3rd, the following year or something like that, unless it says something like that, assume that the same year, okay? So June 26th is my first date, and September 3rd, my second date, okay? So I'm allowed to pick whatever year I want because we haven't hit June of this year. How about we use 2020, everyone's favorite year, right? So let's use, yeah, do you even remember June 26th, 2020? No, it's all a blur. So how about September 3rd? No, it's all a blur. So let's just use 2020, but you're allowed to pick any year that you want. Okay. So when the question does not specify the year, you may pick any year. Right? So, but just use the same year for both. Use the same year for both. Okay. For this question, I'm going to use 2020. It really doesn't matter. So for this question, I will assume the year is 2020, everyone's favorite year. Okay, so that's just kind of a side note. If you come across something where it actually doesn't specify what year it is, then you're free to pick whatever year you want, your favorite year. I don't know, 1997, life is good. Spice Girls are at the top of their game. What can go wrong? So, doesn't matter. On June 26th, Laura put $2,750 into a term deposit until September 3rd. Okay, so we have the time frame, not explicitly, we'll have to find it, but we know from June 26th to September 3rd, all we have to do is find the number of dates, which we'll get into. But let's just read the whole question first. When she needs the money for, so September 3rd is when she needs the money for tuition, books, and other expenses to return to college. What a lucky girl Laura is. For term deposits in the 60 to 89 day range, presumably our answer for T is going to be somewhere between 60 and 89 days, otherwise the question doesn't make sense. Her credit union pays an interest rate of 4.25%. Good luck for that, but anyways, matter. It's just me being bitter. How much interest will she earn on the term deposit? So how much interest will she earn? So the amount of interest is I, right? And so we're trying to solve for I here. So let's just pick apart some of the things that were given here. And instead of kind of pulling it off and just kind of doing it up here, it gets a little bit tight, right? And so what I'm going to do is down below here, I'm going to write that we're given. So here are some things that we've been given. Date one is June 26th, and date 2 is September 3rd. So let's just jot those down first. So date 1 is June 26th, and I'm assuming 2020. Date 2 is September 3rd. And again, I'm going to assume 2020. Because I know I have to use this to find T, there's no sense in kind of avoiding it. I'll just put the days between dates here and with a little star to show that that's what I have to calculate, right? So I'm given the days between dates implicitly, right? Kind of with the dates. So while I'm at it here, I'm going to convert these dates into the month, dot, day, year format. Okay. And if you have a little, so on your formula sheet, right, it's definitely a good idea until it's kind of ingrained in your brain, month, dot, day, year. Because it's not intuitive. But that's how we have to have the date. Okay, so month, day, year. month, dot, day, year, even weirder. So if I convert June 26, 2020 into month, dot, day, year, this becomes 06, right? June is 06, yep. Dot, and then dot 20, or sorry, no dot there. 06.2620. September is the 9th month. So 09, 03, 20. Okay. While we're here, we may as well just calculate the dates between dates here. So what I'm going to do is I'm going to enter these dates into my calculator, and okay, I'm going to try to remember these. So let's see here, I'll clear. So I'm calculating the days between dates, so it means I have to go to my date menu, second date. So now I'll change date 1 to be June 26, 2020. So 06.2620. Notice that it doesn't have 06, it just has 6. That's okay. I always just enter it just in case, but doesn't matter. This isn't stored yet, right? Because it hasn't changed it to that format that we're used to seeing. So you have to hit enter, right? And use that as a reminder, right? If it doesn't look like that, right, 6-26-2020, then it's stored it yet. Okay. That's my start date. My end date, right? I have to scroll to date 2. Yeah.
Which button you use to change it into like this dash one, like from decimals to dash?
Sorry, say that again.
Which button you chose to like shift the decimal to like the dash one, like 6 dash?
You have to hit enter.
Enter. Okay.
Do you see the one that I'm hitting, the enter button?
Okay.
Okay, good. So now I'm going to do it again with the second date. So I enter September 3rd, 2020. September is 09.0320. And then to store it, I have to hit enter. So enter, and now it's stored. And you can scroll between these just to make sure that things have stayed, where they are, but they will. So, but especially if you think, oh, I forgot to hit enter before I moved on, right? Then you can scroll between these and kind of check it out. So now, if you scroll to the days between dates, which is the one that we're trying to calculate, right? Don't think that it'll compute without you forcing it to hit compute, right? So the CPT button is compute in the top left-hand corner. So you have to hit that, otherwise it's not going to update. Okay, so here I'm on the screen that I want to solve for, and then I hit compute, and I'm finding that it's 69. So there's 69 days between June 26, 2020 and September 3rd, 2020. Okay? So you have to hit compute, otherwise it will just have the same value from before. So we find that this is 69 days. So what are we given then? Well, then we're given that T is 69 days, and in years, 69 divided by 365, right? So then therefore, T is 69 divided by 365, right? That's the amount of time that this investment is sitting there for. Okay. So that's kind of the first chunk of information that we're given, and kind of it's a lot of work that we have to do to find T, but then when we have T, it becomes an easy problem, right? So our initial investment, P, principal investment, is $2,750, right? And then, like it says here, and just like we suspected, for term deposits in the 60 to 89-day range, we have 69 days, so that is the range that we're in. The interest rate is 4.25%. And we want to find I. So let's just write down that P is 2750. So P is 2750. The interest rate was 4.25% or 0.0425. Right, as a decimal. You want to be really careful that you don't throw a percentage on here because 0.04% is really small. 4% is quite large in terms of interest rates, right? So you have to be really careful with the percentage sign. And we want to find I. Find I, which is the amount of interest. Let me just make sure. Yeah, it is 4.2. Okay. So I is PRT. Well, now I've done all that work to find T, and that was the hardest part of this problem. So P is 2,750 times R, which is 0.0425, times T, which is 69 over 365. Again, because I'm just multiplying and dividing across here, it actually doesn't matter which order I do it in. You should end up at the same value that I do, regardless of how you want to go through and do this. But that's only because we're multiplying and dividing. So the hardest part, right, is reading the problem and figuring out what information we're given and what we have to solve for. Then actually solving for it, right? The math aspect of this thing is not hard, right? It's reading the problem and figuring out, okay, what do we have to do here? Right? Picking it apart. That's the hard part. So if we do this on our calculator, right? Okay. We had 2750 times 0.0425 times 69 divided by 365. So I get 22.0941788. 22.094, I can't remember. It doesn't matter, right? Keeps going. I'll just do ... because I don't want to switch between the screens again and confuse everything here. So the amount of interest is $22.09, right? That she's made between June 26th and September 3rd. This Laura character is pretty lucky. She doesn't need a ton of money. It is a lot, but I mean, in terms of tuition and books and everything, $2,750, but then also the $2,209 from the interest that is earned, right? So by September 3rd, how much will she have in total? Well, she'll have $2,750 plus the $2,209, right? And so notice, only because it's where we're headed in the next section here, notice on September 3rd, Laura will have the initial $2,750 plus the interest $2,209, which is what, $2,772.09. because you add those two together. Okay. So that's where we're headed in the next section, is trying to figure out, well, okay, who cares about the amount of interest? I can easily find the amount of interest later. As long as I'm able to say, okay, 2750 in those 69 days grew to 2772.09, right? So that's where we're headed. Basically, for the rest of the course is taking some initial amount, and then it's going to grow to what we'll call our future value. Okay. So section 4.4, kind of a nice segue into 4.4, is on the present and future value. Okay, so if we invest some, and it's just easier and just kind of nicer to talk about investing money, but just kind of remind yourself that, well, borrowing money behaves the same way as I'm on the other end of it, which isn't that great. So if you think about it, when you invest money, the bank is borrowing your money, right? They're expected to pay it back and have it be right, but they are borrowing your money, and so that's why they pay you interest versus a loan where you borrow money and then you have to pay the interest because you borrowed their money. Right, but that's the same exchange. It just depends on which side you're on. So the present and future value is going to be really, really important that we have a good handle on which is which. And at least here in the beginning, it's going to seem really silly, but we're going to ramp it up to harder problems where it's not going to be as obvious. So just kind of make sure that this makes sense when we're talking about it. Okay, so let's just talk about investments, but then in your mind say, okay, well, it works the same thing for loans. So if we invest some amount P, which is the principal or present value for some amount of time at some interest rate R, right? We're going to make so for some amount of time T at some interest rate R, we make some amount of interest, which is that capital I. We make some amount of interest I. Okay. In total, though, the amount that we'll be able to withdraw, we call it the future value. Okay. So in total, the amount we're able to withdraw, or the amount we can withdraw at the end of the investment is called the future value. The future value, which we'll denote by FV. Now the future value, right, just like we said up here, said, okay, well, at the end of this term, right, the investment term on September 3rd, that's the end of it, right? She's going to have the initial amount, right, P, plus the amount of interest, which is going to be our total future value. So here, this is our future value. Okay, so I'm just going to emphasize that here, that this is P plus I becomes our future value, which is the total amount able to withdraw. Okay. So now we can kind of see, okay, well then the future value, that's just got to be P plus I. Okay. What gets annoying is you don't want to always be finding I. So we actually have a better form, an easier formula for future value. But of course, I'm going to show you how we got there. So notice that the future value is the principal amount plus the amount of interest. Now, this is where it becomes important to remember the definitions of these variables, right? P is the initial investment plus the amount of interest earned. Initial investment, and I is the amount of interest earned. And that's the total value of the investment at the end. Total value of investment at the end. That doesn't look like me. There. Okay. So if we remember I, right, we have a formula for I. So how I'm going to morph this formula is I'm going to say the future value is P plus I, start there. Just copying it down so I don't have to span multiple lines here. But I can replace with PRT, right? Since I equals PRT, right? That's the formula that we've been using so far, right? So I can rewrite it as PRT. Notice that I have a common multiple of P here, which I can pull to the outside. So the future value becomes P times 1 plus R times T, right? When I expand this P inside here, I have to end up here. And that's why you have to remember this 1. So this is the formula on your formula sheet, right? And so let's go to your formula sheet just briefly here. We'll just nab and say, okay, well, this is this formula here. Okay. So this is how we get to that formula. But of course, a formula on your formula sheet, you're allowed to just use and apply. You don't have to develop it every time. But what I also want to say is I think many people want to just start using formula all the time. You can, as long as you remember that the total amount that you have at the end of the investment is P plus I, then that's fine. But in general, using this formula is going to be easier if you want to find the future value. If you have the future value and the initial amount, you can easily find the amount of interest, right? Future value minus P, right? So we just have to remember, but intuitively we know, okay, so I invest some amount and then it adds interest, and at the end I have both of those, right? The initial amount and the amount of interest, right? And so just keep that intuition still in your mind, right? It's still going to work, but we need to have the formulas as well. Okay, so let's do let's do an example. Nothing's changed here in terms of R and T, right? R has to be as a decimal and it's the annual interest rate, and T has to be the time in years still, right? So let's see here. Let's do example 141. I'll put it on a new page here. So now the future value is the maturity value. And so here I'll make a little note, maybe up about here. Note, future value is also called the maturity value. Which I feel like you would probably figure out from the context, right? And so calculate the maturity value of a $15,000 investment at a simple interest rate of 4.75% after 1.5 years. Now there's a lot of, it's a nice short question, but there's a lot of information here. And there are a couple of things that I want you to keep an eye out for. So for the first part here, right, we want to calculate the maturity value, which just means find the future value, right? The initial investment is 15,000. So this is P equals 15,000. Now, for now, all we've dealt with is simple interest. Later in chapter 5, then we're going to start introducing compound interest. And so then on the next test, for example, you're going to be given simple interest problems along with compound interest problems. And that's when you have to decide, okay, which formulas do I use, because they'll be different. And so the first question that you're going to ask yourself is, do I have simple interest or compound interest? So here, when you read simple interest rate, then you know, okay, this is a simple interest problem. So we're going to start classifying. When we read a problem, we're going to start asking ourselves, okay, is it simple interest or is it compound interest? Of course, we've only looked at simple interest so far, so all of these problems will be simple problems. But what I'm saying is later, that's not necessarily the case, right? So then you need to pay attention to stuff like that. So here, right, this will be important later. We'll need this for later sections, right? So we'll need to pay attention to, does it say simple interest? If so, yes, okay, we've got a simple interest problem, and those are the skills that we're developing right now, okay? Later, the problem will say you have a compound interest rate of this. Okay, then you say, okay, a compound interest problem, those skills will develop in chapter 5. Okay? So, and it's one of those things that people have a hard time figuring out. Do I have simple interest or compound interest, right? Well, what does it say in the problem? For now, we are working on simple interest problems, so is it simple interest? But I just want to highlight that that's going to come up. So we have a simple interest rate of 4.75. When it doesn't specify that it's annual or per year or whatever, we can assume that it's per year, right? So here we've got R equals 0.0475. Notice that I convert it to a decimal immediately. Sometimes I will, sometimes I won't. But definitely for now, right? Especially if I'm just jotting it down, like kind of crammed, then I just convert to a decimal right away. After 1.5 years, that's good. Okay, so we don't have to do any conversions for t. So then t here, t equals 1.5. Okay. So because it asks me to find the future value, I'm better off just using the future value formula, right? And so here, let's say, okay, we're going to use the future value formula, which is P times 1 plus R times T, right? And that's just from your formula sheet. As soon as it's on your formula sheet, you're allowed to just use it, okay? So you don't have to develop it or anything like that. You can just use it. So here, kind of BEDMAS stuff to keep in mind is we have to deal with the brackets first. So in general, right, we need to deal with the brackets first, and then we can multiply by P. Inside those brackets, though, you need to do R times T first, and then add it to 1, right? That's a really common mistake that I see. People want to do 1 plus R and then times T. That's going to be all wrong, right? And so illegal math. So you have to do R times T first, right? And then add to 1, and then multiply by P. Okay, so let's just make a note here. Step 1, multiply R and T. And then step 2, add that to 1. And then step 3, multiply that by P. Okay. So make sure that you follow BEDMAS here, otherwise it's going to be really long. And since we're talking money, that's kind of a big deal. So, all right. Let's figure out, okay, what information do we have here? It looks like I have P. I know I want to solve for the future value. Okay, so that's fine. 1 is just 1, so that's fine. I have R and I have T, so it looks like all the information is here. I just need to plug it into the equation. Okay, so let's do that. So then the future value, which I'm solving for, is P, which is 15,000 times 1 plus 0.0475 times 1.5. Note that I'm just using brackets to multiply, right? And so I want you to move away from X multiplier because it can get really confusing if you've got kind of X's or something that looks like X. And so just use brackets or a little dot if you want, but I use brackets. So here, how I show these steps in my work is, okay, at each step in my work, right, I'm just gonna simplify each of these portions, okay? So this becomes, so the future value, what you'll notice is if nothing's changing on the left-hand side or on the right-hand side, I just leave it be until it changes. Or at the end when I want to summarize. Now, I'm gonna just cheat and pull up my calculator on the side here because I do want to copy out numbers. So 15,000 stays on the outside times 1 plus, and then 0.0475 times 1.5 is 0.07125. Now, this became a nice number. You're going to keep all these decimal places, right? So here must keep all decimals, right? Especially if it kept going on and on and on, then you would have to store it, right? Or just go straight to the next and add 1 to it, right? So sometimes I'll just kind of do a little link calculation in my calculator, right? Where I have that on the screen, and then I add 1, okay, and then I write that down, and then I multiply 15,000, and then that's how I keep all my decimals. However you do it, just make sure you keep all your decimal places. Otherwise, it will be wrong. So then it becomes 15,000 times 1.07125. Right, so just add 1. Then I can multiply by 15,000. Putting me at 16068.75 even. Can you believe it? Okay. So I don't need to do any rounding. It's just kind of nicely figured out. What does this mean? Right? This means that, okay, I invested 15,000 for 1.5 years, and at the end, I'll have $16,068.75. That's my future value, right? If I asked you how much interest did you earn, you can find that intuitively, right? The amount of interest is the difference between 15,000 and 16,068.75, right? And so after 1.5 years, 15,000 will grow to 16,068.75. Here's kind of a check-in point, right? You're expecting it to grow because it was an investment. So if you've done a calculation where you're telling me that 15,000 grew to 13,000, that doesn't make sense, right? So that's when I want you to check your work and just make sure that you did it right. But you want your final sentence to make sense, right? Typically, I'm not going to be looking for a final sentence. I'm only looking for the answer, right? The number answer. But you should be able to formulate it as an answer. But usually I just reword the question as an answer if I have to do that. So I'm not going to do that. But after 1.5 years, 15,000 will grow to 16,068.75. Okay. Which means that we've made how much interest? Which means we made, right, the difference between these two, so 16,068.75 minus 15,000. Oops, minus 15,000, I don't trust my math here. 1,068.75, I guess I should have been able to do that. In interest. Okay. So here, right, notice since the future value is P plus I, right, I must be the future value minus P, which you would know intuitively anyways, right? If you didn't have that formula, right, you would say, oh, okay, well, if I ended up at 16,000 and I started at 15,000, everything in between there is interest, so I know it's about 1,000. Good. So what we're going to start doing is, or maybe before we do that, let's take just a quick break. I know that was a big question. So let's have a break and I don't know, I want to do a 5-minute break, but now it's 11:07, so things got weird. Break until 11:12. Or how about 11:11, November's Day? Just a quick break. Grab some water or whatever. Okay. So we're all refreshed. All right. So what we're going to be doing is, so far we've only seen kind of simple problems, right? We haven't seen a lot of problems, but what's going to be really important is being able to map out the situation. And what we call a time diagram or a time graph or some sort of timeline, right? And so we want to be able to graph situations in order to kind of simplify the problem, right? And so in order to solve more complicated problems, we will use a time diagram or a timeline, or I'm trying to think of what we call them. Anyways, I call them a timeline. We will use a timeline or a time diagram to illustrate what's happening in the problem. To illustrate what is happening in the problem. So far, right, what is going on, right? Our very simple time diagram so far is going to have, you make a deposit on some date, and then it sits there for some amount of time and it becomes a future value, right? And so where our timelines will start, right? And so so far we have seen this, right? So I'll start my timeline here. Yeah. And just to link it to the days between dates calculation, I'll put date 1 here and date 2 here. Right, that's the end of my deposit. Sometimes the amount of time will be kind of in 1.5 years, like it was in the previous question or something like that. But in general, what we're going to do is we're going to put the dates up above here. Okay. And so the anatomy of this thing is going to stay the same for the rest of the course, right? I'm going to put dates up above here. So then what I'm going to do is I'm going to say, okay, in general, some initial investment fee, okay, and sometimes I'll even do a little box around here, especially now that we're just talking about it, right? So that's my initial investment, and it's going to sit there and grow. And so notice that this P, I'm doing the calculation this way, so I'm doing an arrow to the future value. I'll put a box around that too, just for emphasis. Okay. So now on this arrow, what I do, because, okay, so I have date 1 and date 2, that's not the time. right? And so how I'm going to do this is on this arrow, I'm going to indicate what the time is, but also what the interest rate is. There's no way to visualize the interest rate, so I just need to jot it down here and just kind of have this graph as the summary. So what I do is I have t equals some, let's say, days between dates, for example, right? Or just the time in years. And R is the interest rate. Interest rate as a decimal. Okay. So this is how you're going to draw out your timelines. What's going to happen is, okay, so let's say you invested $1,000 on August 1st, and then you had an extra $200 left over on September 30th. So then you made another investment September 30th, and then that's going to grow to a future value as well. Right? And then at the end of this investment here, you're going to have a total investment, which is going to be the sum of all those. Right? So that's just a sneak peek at what's going on here. So being able to summarize the problem kind of in this timeline is going to be real important. What actually ends up happening is the majority of your marks will be from your timeline, right? Because that's how you summarize the information that you're given, and then the calculations themselves not hard, right? It's figuring what information you have. That's going to be the hard part. So let's see here. Let's see if we have another example. Let's do 144 here. What amount should be invested today? Okay. This is different than what we've been solving for, right? In order to receive a maturity value of 17,000. So now I'm told the future value and I need to find P, right? That's kind of the opposite of what we've been doing. We found the future value before and we want to find P, right? So, and this is how all these sections are going to go. We're going to be able to do one example solving for each of the different scenarios, right? But we will see all the different scenarios, but potentially only once or two times maybe for harder problems. In 8 months, if money earns 9% simple interest, so there it is again, right? Later on when we're reading and we're trying to figure out, do I have a simple interest problem? Yes, I do. Right? And so just convince yourself, okay, yeah, all these are simple problems. Great. It's all covered so far. Of course, they're simple problems. But like I said, later on, that's important. So we want to find P given that the future value, so now I'm just going to summarize kind of below here because it gets to be a bit much. The future value is going to be 17,000. T is given in months, right? But I need to convert that to years. And again, we assume that we have 12 months. We do have 12 months in a year, so 8 divided by 12. And then the interest rate is 9%. So R is, so here, because I have space, I'll do 9% or 0.09. Right? So here, this is an easy problem, right? It's just that we haven't found P before. And there are a couple of ways that we could do it. We could just solve for P in general in the formula, or you can plug in these values and then rearrange and solve for P. It doesn't matter what you prefer, but so for this type of problem, you don't need a timeline, but to get in the habit of using timelines, I'm gonna draw a timeline. So, or we can show this information using a timeline. Okay. So sometimes it gets a little bit vague on what the start date is and what the end date is, but as long as you know T, that's the whole goal of this thing. In fact, it says what amount should be invested today. So that's going to be my start date today, if I know it. And then here, I know this is 8 months from today, whatever that is. And what I want to show is some P, right? So what amount should be invested today? So what amount today is going to grow to 17,000 under these conditions, right? 8 over 12 the time and 9% is my interest rate. So P, so some P has to grow to 17,000. And on this arrow, I'm going to say T is 8 over 12 and R is 0.09. I will make a little note here that for simple interest, simple problems, of course, context defines which one we're talking about. But for now, I'm going to avoid the word simple. For small problems like this, we do not need a timeline, but it is good to get in the habit. Of drawing them. So of course you don't need to draw them, but it is kind of a good stepping stone to kind of get in the groove, right? So notice how I'm able to summarize all the information because I've just P here is my principal, so of course that's what I have to solve for, right? And so so what happens is, okay, P ended up growing. Sorry, it's lagging. P over 8 months at a rate of 9% grew to 17,000. Okay. And so, of course, I still use the formula, but here I can kind of visualize it. And just as a check-in point, you're expecting P to be less than 17,000, right? If it's going to grow to 17,000, you're expecting this initial investment to be less than 17,000, right? Just as kind of some check-in points. In general, on your timeline, the P is always to the left and the future value is always to the right. It's always moving into the future. So now we have to use that formula. The future value is P times 1 plus R times T. Since we want to find P, we could solve for P first. We could solve for P in general. and then in values. Okay, this might be a good idea if you're solving for multiple p's, right? And so this would be beneficial. This method would be beneficial if solving for multiple p's. Okay. Which we will see, we just haven't yet, right? So then, okay, so let's see here. If the future value is p times 1 plus r times t, and I want to isolate p, so you want to hold p steady, then this whole number 1 plus rt, I can divide over to the left-hand side, but then I also do that little swivel thing. So p becomes the future value over 1 plus r times t. Now again, you want to be careful, right? Because you want to simplify the denominator and it becomes the same steps, right? You want to multiply r and t and then add it to 1 and then divide the future value by that number, right? So just be careful with that BEDMAS. So if you have to solve for multiple values of p, then maybe just having the formula ready to go is a nice option. In our case, right, or we can plug in values, plug in the given values, and solve for p. So in our case, right, let's write out the general formula again. The future value is p times 1 plus r times t. So we'll grab the information that we want or have, and then we'll solve for p that way. The future value, we're forcing it to be 17,000. Right, it has to end up being 17,000 is p, which we want to solve for, times 1 plus r was 0.09. Sorry, it's just catching up. R was 109, and let me just hold my, oops. R is 0.09 and t is 8 over 12. So 109 times 8 over 12. Remember that you have to multiply 0.09 and 8 over 12 before you add it to 1. Okay. So to show that, I'm going to do that in each step. I'm going to do the calculation in each step. And that's how you're going to be able to read my work to see what are the steps that you have to do, what's the proper steps that you follow. So 17,000 is p times 1 plus, and 0.09 times 8 divided by 12. Again, because just multiplying and dividing in here, I can do it in any order. It puts me at 0.06. Okay. Next step, I have to add 0.06 to 1. Okay. So 17,000 p times 1.06. Okay. This 1.06, just as a side note, it behaves the exact same way as when we calculate the price plus tax, for example, right? Times 1.12 for tax in BC is 12%, right? So this 1.06 times p, well, it just makes sense that it would grow to 17,000. So now if I have to solve for p, then I have to divide by 1.06 on both sides. So then this becomes 17,000 divided by 1.06 is p. oops, sorry, 17,000 divided by 1.06. So P I find is 16037.73585. This is dollar amount, of course. So I round to 2 decimal places, 16,037 and then 74 pennies. Careful with your rounding there. Just do a quick check, right? 16,037.74 is less than 17,000, so that's a good starting point. That's what I'm expecting it to be, right? And is it reasonable at 9%? Yeah, sure, sounds reasonable. For 16,000 to grow to 17,000 in 8 months. Wow. Kind of unrealistic, though fun to think about. Finding an interest rate of 9% is going to be very difficult these days. I say these days, probably in my lifetime it has always been, or at least like financial lifetime. Interest rates are just low. That's okay. So, all right, let's do another problem here. I guess we should answer the question. Like I said, I'm not putting a lot of emphasis on the sentence answer. I do expect you to be able to answer as a sentence, but so what amount should be invested today in order, oh, sorry, just let it catch up here. What amount should be invested today in order to receive a maturity value of 17,000? $16,037.74 should be invested today under these conditions for it to grow to 17,000 in 8 months at 9% simple interest. Okay, ready to kick it up a notch? So the last problem, and this is the one that I added to the handout because I wanted you to see kind of a big beast. Not a big beast, but for us, right, from what we've been doing, this is a big beast. This is also the last kind of basic problem that we're going to have, and then we're going to solve for R and we're going to solve for T, but we're just manipulating this one formula, the future value equals, oh, so annoying, this lag is killing me. We're just manipulating this formula for the rest of the sections now, right? And so the future value is P times 1 plus R times T. Of course, in the next few sections, we're going to solve for R. We're going to solve for T, right? We're going to do problems like that. So we've solved for the future value. We've solved for the P, the principal amount, or later we'll call it the present value. So now let's do kind of a bigger problem, solving for either the future value or P. All right. So here, this is the type of problem where timelines are going to be super, super useful. All right. Okie dokie finance company advanced 3 loans. So we're 3 different loans to D. 2,200 on June 23rd. Okay, so that's your first amount. And then she borrowed 1,800 on August 5th, and then she borrowed another 1,300 on October 31st. Okay, so she's got 3 loans, and so she just kept borrowing money. Simple interest, right? So just kind of make a little mental note. Okay, so it is a simple interest problem. Of course, we are only dealing with simple interest for now, but for later, that's going to be really important. Simple interest at 7.25% was charged on all 3 loans. So that's another thing that could happen is the first loan was at 7.25%, second loan was at 4%, third loan was at 3%, something like that, right? So just keep an eye out for that stuff. But in this case, 7.25% was charged on all three loans, and all were repaid on December 31st when some bonds that she owned matured. I do think it's really funny when they just kind of try to explain what happened. It doesn't matter, but December 31st, that's when all of these loans are being repaid. What total amount was required to pay off the loan? Okay, so just take a step back and in your mind map this out, right? So she had a loan on June 23rd. So her first loan, okay, for 2,200, and then she took out a second loan for 1,800, and then she took out a third loan for 1,300 at different time points, but then they were all paid back on December 31st. So in terms of our timeline, there are 4 time points that I'm interested in, right? So the first one is June 23rd, then August 5th, then October 31st, and then of course I'm also interested in the date that she paid these, December 31st. Okay. So for our timeline, a good starting point is how many time points am I interested in? You can always add more if you find that you're missing some. But what we'll do is draw our timeline and make sure you use kind of most of your page here because we have to squeeze 4 time points on here. So we've got the start and the end date, and then I try to space them out kind of evenly. You do not need to make them look like, okay, the distance between June 23rd and August 5th is this much. No, this is just to visualize, right? This could be 6 months, this could be 5 years, right? So the first chunk, it doesn't have to be proportionate, okay? It's just to visualize what's going on. Okay. So what I'm going to do is, or what we are going to do is we're going to jot down the dates. The dates go above each of these time points. Okay. So here I have, I have June 23rd. There's no year given, so let's use 2020 again. You can use whatever year you want. So June 23rd and August 5th is the next time point, and then October 31st, and then December 31st. Okay. So just as a note, right, dates go above the timeline. Loans work the same way that investments do, it's just not as fun, right? Now you have to pay the interest, right? But they behave the same way. So what you're going to do is below each of these time points, now you're going to put the dollar amounts. Okay, so each of the dollar amounts that she borrowed go underneath here. So under June 23rd, I'm going to put 2,200. Under August 5th, I'm going to put 1,800. And under October 31st, I'm going to put 1,300. And then, so here, I'm just going to summarize, put dollar amounts below the time points. Okay. So the interest rate is the same for each of these. So I'm not going to draw that on each of the lines, although you definitely can if you want to, because notice that each of these loans is going to have some future value on December 31st, right? So how you're going to draw these is you're going to have these arrows going from these three loans to some future value on December 31st. And we're going to have to calculate three separate future values to figure out the total amount that she owed on December 31st. To do that, to make our timeline a little bit cleaner, I actually start at the closest one and draw the arrow. I move out to the next one, and that's just so my arrows don't overlap, right? It just kind of makes a mess. So 1,300 is going to grow to some future value that I don't know what it is. So what I'm going to do is I'm going to call this a future value. I'm going to put a subscript 1 because I already see that each of these are going to have some future value. So I need to be able to refer to them. So I'm going to call this future value 1. Or 3, if you want to think about 1, 2, 3, it does not matter. I use 1 because it's the first one in the list, but it really doesn't matter. So then this 18,000 is going to also go to December 31st. And it's going to owe, so she on this 1,800, she's going to owe some future value 2. And then finally, I'm gonna, oops, sorry. Gonna just bump this down just a little bit so I have room to draw this arrow because I want it to look nice. That initial 2,200 is also going to grow to some future value. So here, I'm gonna say, just as a little note, use subscripts to keep the different future values apart. Right, so just kind of some way, you could call it future value A, B, C, it doesn't matter. I use 1, 2, 3. Because we're gonna have to solve for each of these independently. And then we're also gonna show that what we're actually interested in here is the sum of these, and this is the total owing on December 31st. Okay. Okay. So we've got dates. We don't have the year, but we're just going to pick a year, like I said, and then we're going to use the same year for each of these. So that's how we're going to find the T. So notice 3 separate days between dates calculations. Yikes. Okay. So what I'm going to do to kind of remind myself is, because I call this future value 1, I'm going to call this T1. And I'm going to say that it equals something, but I actually have to do the days between days calculation to find it. But then T2, same deal, and T3, same deal. Right, so I use the same subscripts, okay, to keep these separate calculations, or these calculations separate. And then in general, somewhere around here, I'm going to say R is 0.0725 for all. Okay. It's a lot of information, right? But notice how when we map out on the timeline, we can kind of see what's going on here. And we also see some things that we need to find before we can calculate each of these future values, right? But this becomes a roadmap of all the things that we're gonna do. Okay, so we need to use the days between dates calculator. We need to find the days between dates. Okay. I'm going to do these side by side because there's not, a ton of information. So to find T1, date 1, date 2, and then the days between dates is the one that I'm calculating, right? So I put a little star here. Just as a side note, remember it's month, month, dot day, year. So what I'm gonna do is I'm just gonna translate each of these dates into month, dot day, year. Noticing, right, date 2, sorry, it's still catching up. Date 2 for each of these is gonna be December 31st, right? So that's important. But also it makes it a lot easier because that means I don't have to change date 2. Once I've entered it once, I can just keep it as December 31st. So date 2 is the December, so let's just jot that down. December 31st, let's use 2020. Let's use 2020 as the year. Doesn't actually matter, but okay. Notice that this will be date 2 for all. Okay. So if I set up for time 2, date 1, date 2, I don't need to change it. And then the days between dates, the one I'm calculating, and then also T3, just to kind of keep it on the same, so I'm not scrolling so much. I want to keep it on the same page. Of course, if you wanted to stack them, that's totally fine. Date 1, date 2, and the days between dates. So this is how I want you to show your work, right? If you're using your calculator to find the days between dates, you have to show me how you did it. It's kind of a weird thing, right? Because we're not used to showing math this way, but that's what we're doing now. You don't want to confuse yourself right here. T1 actually from October 31st. Sorry, it's just catching up. From October 31st to December 31st. So from October 31st, we will have October is the 10th month, 10, 31, 20. I think it was October 31st. T2, right? Just kind of remind yourself what you labeled to. It's from August 5th to December 31st. So we want August 5th as our T1. 08, 05, 20. And then of course, date is 12.31.20. If nothing's changing, you don't have to change it on your calculator, but I'll show you. And then date 1 for that last one, which I'm calling T3. And I understand that can get confusing, but you just want to figure out a naming convention that works for you, right? So for me, this works, but if you're getting too confused, then absolutely just change it. T3 is from June 23rd to December 31st. So June 23rd is 06.23. 20, and of course date 2 is 12.3120. So I know I'm out of time. Definitely try these on your own, right? Try solving this whole problem on your own, and then we'll pick up here today, and we'll actually do these days between dates calculations. Right? But you have the hard part is over. Just remember you need to solve for 3 separate future values here, and then add them up. Okay? All right, so didn't quite finish. That's okay. We'll finish the next day. If you have any questions, let me know. Otherwise, I will see you on Thursday. Thanks, guys.